Another draft physics presentation. I probably should make sure I have disk space. Excuse me for a minute. Don't need to have a mistake of catastrophic nature and such. Do have a couple of big files on there, so we'll delete those and move along. All right. Anyway, sorry. I had already hit the button. I just don't want to do it over again. Sorry. Shit happens and such. All right. So Holiday has made a fortuitous video, I suppose, when you really think about it. Just because he's sort of made some claims that just aren't going to work out for him, and I'm sure of that. I mean, either way it goes, I win, sort of claims. So, so he just made a video where he's playing my video, but he's playing so little of the content of the video that it just doesn't make any difference. And he whines that my videos are too long, and I understand they are when I'm doing response videos. So don't, find a video that's not a response video. And clearly you'll be able to glean out of it points. I don't even mind you skipping through videos that are describing different experiments, but I mean, it's not that hard to get the argument. So I can make a 3-minute video or 4-minute video, and I'll just recite all the arguments you haven't answered, like why the 2-slit pattern and the single-slit pattern, even in photons, doesn't wave the way it's supposed to. And then I can argue about the single slit and the double slit and the little slippery changes they make in the mathematics and in the variables. It's a Huygensing in the single slit and creating 2 photons, and all of a sudden the same slit, when next to another slit, all of a sudden Huygens is in a whole different manner and doesn't create 2 photons anymore, just 1. And then we can get onto this, interferometer, other things. But, these are all weaknesses, signs of weakness in your theory. And you don't claim them to be signs of weakness. You somehow think, okay, you have an explanation that's valid, and you don't provide it. You just go, well, it's the intensity of the light or something. Well, anyway, so I took some notes of the first half. I watched the first, 30 minutes, and then he went back to the beginning. So he plays like 3 minutes of my video, and then he goes back to the beginning, plays it the same shit all over again. Inanely stupid. Anyway, so I say, if I make a 10-minute video outlining the problems I see in quantum mechanics and relativity, will you play it and respond to each of the points made? So I wrote that before I saw the video, where he makes a couple of efforts to justify things that don't make sense. And clearly his answers aren't going to be anything like a real answer, so there's no point. But anyway, I wrote that before I knew there was no point, because he's not going to really provide an answer. I have made videos where I paraphrase your arguments and provide responses, so it's just to his accusation that all my videos are the same, which they're not, and there are videos where I'm drawing pictures or doing other things, and clearly you could play one of those. Alright, he claims his bold assertions are not antagonistic, so he's somehow claiming that I'm the antagonist by questioning quantum mechanics. Essentially, you're an antagonist just by saying, I don't understand why that happens that way. That seems curious. Those are antagonisms. And him saying bold things like, there's no particle model that ever in the history of all existence in the universe could ever explain anything, kind of assertions, should just not be considered antagonistic at all. Right, somebody walks up to you and says, evolution is wrong, my God is God, and that's not antagonistic. Okay, gotcha. He claims the classical explanation of the interferometer is quite simple. Okay, now, that to me is surprising, that he thinks there's something like a simple explanation. Like, you could draw it like a 2-slit experiment. Just draw me the interfering waves and show me where they're interfering in the interferometer. If it's a simple experiment, you should be able to do that. So why don't you do that? So it doesn't seem like a horrific request that you, even with Huygens, nobody ever draws an infinite number of little wavelets, but just give me the idea of it. So give me the idea of where the interference is happening in the interferometer experiment. That doesn't seem too challenging. It's supposed to be such a simple experiment. All right, there is a simple explanation for where this single photon interferes with itself. So again, if you understand quantum mechanics, the obligation of interference is that you have to have it with a single photon interfering with itself. There's no examples in any quantum mechanics that I know of where two independent photons interfere with each other. That doesn't happen. Now, as far as I know, if you got evidence that science believes, or quantum mechanics believes, that individual photons, separate ones, interfere with each other, then show me the evidence. I never heard of that. Yet he's claiming that's something to do with this experiment somehow. I mean, that's what he was saying the other day when he was talking about there's a whole bunch of photons going in. Anyway, he claims waves fit any phenomenon because of the mathematics. He claims waves fit many phenomena because of the mathematics. So again, this argument that somehow the math is Huygens and Heisenberg and all the other crap they engineer to create, let's say, the sine theta. So the fact that they create an angle that they sine, which means they turn it into a proportion, that is a percentage. So the angle is essentially a percentage of a 360-degree hole, especially when it's put into arc seconds. But anyway, so that's what the purpose of sine theta is to do, is to essentially do what I'm arguing. That is, create a standard angle that everything is moved by. So, yes, again, I'm not disagreeing with the elements of the mathematics. I'm not disagreeing that the slit opening is relevant, and the frequency is relevant, and the distance from the target is relevant. I'm arguing that your argument about how those variables interact with your presumptions of Huygens, that's what I'm arguing. But that's too complex. See, you can't follow along. All right. Let's see. I would claim that the fit is far from perfect. So he says he claims the fits all the phenomena, yet the evidence demonstrates that the fit is far from perfect. So again, that's my counter argument, that all I'm asking these jackasses to concede is that there is room to critique these theories because they don't function perfectly, and that should be examined. Because if you are on the wrong track and somebody points it out to you, another train could be coming down this track because you're on the wrong track, or this might be the track to nowhere, or it's a track off a cliff, and these people are just totally obnoxious to people saying, yeah, I think you're on the wrong track. It seems like you're heading to a brick wall. No, that's offensive. Okay. He claims I haven't made arguments pointing out the weakness of your correlation, and pretends I haven't made quality arguments for alternative possibilities. So I'm pointing out that there's no correlation, no consistency between the pattern in the single slit and the double slit and other interference patterns that are demonstrated, because they all have a probability, and the probability is usually in location, not distances. So the distances are usually always very consistent, and the interferometer doesn't have a pattern that's consistent with those other experiments that are called interference. So that should be like one of those little warning signals that maybe something's wrong here. Maybe they've made some wrong assumption somewhere because it doesn't fit. And that's hugely offensive to him. And then he argues beyond that and says somehow I haven't made explanations for a particle model, an explanation for how this could just be refraction and divergence. Now the divergence argument's a winner, I'll just let you know. And it might be the whole mechanism for why interferometers are useful at detecting movements and vibrations. Why it's a sensitive instrument. It's a sensitive instrument for the very reason of the divergence. But anyway, we'll get to that. He's not playing my most recent video on the subject, so that's another problem, just because this has been kind of a moving target in a sense in the last 4 days, I've acquired new information. And that new information adds up to the old information. So 2 weeks ago or 3 weeks ago, I was talking about divergence. Probably 2 months ago, right? I mean, it might be 3 or 4 months ago that I brought up the subject of divergence, because a half-silvered mirror is essentially a diffraction gradient, and it's got a bunch of little slits in it, and the slits diverge the light, and that's just going to be turned out to be a fact. I think that's just a fact you can't undo. And so I was talking about this idea that the two beams don't have the same amount of divergence. But the real point is the beam that diverges a lot would be very sensitive in detecting changes in distance, because the divergence tells you how far the beam has traveled. So I just draw some picture of that. So you can just kind of understand that if the beam is diverging, you can see that, yeah. So the light is getting fatter as it goes distance. That gives you a perfect way of detecting how far it's gone by just measuring how wide it's gotten. So, and it certainly would tell you if something moved, you'd realize that it would get wider or narrower, and that would give you an indication of that movement. So clearly, I thought it was just a flaw in the experiment. The divergence is actually the function of the experiment. Surprise, surprise. Anyway, all right. Let's see. He claims short interferometers don't create completely dark centers. So he just threw out a bunch of off the top of his head reasons why in the video I showed, which, by the way, is a video of a standard unit they make. And I guess they give it to college students and stuff, that it's for labs. So it's a standard interferometer, like a foot by a foot. It has the mirror built in. It has a micrometer to adjust the mirrors, one of the mirrors. So it's all built out of steel, aluminum, whatever. It's a nice solid little unit that's made for just this purpose as a teaching instrument. And that was the one in the video, because I've seen it and also used by college professors. It's exactly the same. It's like a standard made unit. And he claims that this unit is flawed and broken and inaccurate. Even though it's made to be a teaching tool, it's not working right. Okay. I'm just saying these are off the top of his head excuses for why it doesn't produce this perfect pattern. Yeah, okay. He has no curiosity regarding the fact that the experiment can be performed and produce various results. So the very fact that you can see different demonstrations that are of different refinements doesn't make him think, I gotta look into that. Like, different widths of the beams, and some of them I've actually seen with just lines. Right? They're not a circle, it's lines. But yeah, he's not curious. I make the mistake of saying changing wavelength instead of saying changing in phase. So yeah, so I was talking about the divergence and the fact that it will cause this change in phase because the angles are different, the distances are different. When you hit a mirror here, it's different than when you hit a mirror here in terms of distance. And those distances are quite huge when you think of the phase of a photon. So as I also tried to illustrate, although I don't know precisely all of this metrics, it's true, nanometers are really small. And so even if you have some kind of like 700 nanometer light, you have to do a half a phase change, to really see the difference, go from light to dark. And so that's 300 nanometers. And 300 nanometers is a tiny amount of distance. So when you're hitting a mirror, I can't even illustrate 300 nanometers worth of difference on the slope. because it's so tiny amount of distance. So anyway, but this isn't, no, this has nothing to do with doing science, asking questions and examining the hardware and figuring out what exactly is happening. That's not the scientific way. Scientific way is just accept what they say. Let's see. Sorry, I should try to remember where I left off. Alright, I make the mistake. Okay, yes, so so changing weight, right. So instead of saying changing phase. He apparently doesn't think it's important to understand how small the wavelength of a photon is. So he mocked the whole effort I made to talk about the fact that these are very small, these photons. Their travel distance is very, very small. And that's not relevant in his opinion. It isn't something you should understand, that a millionth of a millimeter is a really small thing. It's a really small amount of movement for any human hand, even through instrumentality. It's very hard to create a physical device that can actually move something a few hundred nanometers. It's such a small amount of distance. It's hard to create gears or any kind of screw drives or any kind of mechanism that's sensitive enough to move something just a few hundred nanometers at a time. Anyway, he says because he is educated, he knows how big a nanometer is. Yet apparently he doesn't think it should. I should attempt to educate people that may not be aware. So yes, so he just claims he has all this superior knowledge, and nobody should ask any questions because no one else should gain any knowledge. Nobody should, I ask the question and maybe you answer the question, like, why isn't the pattern the wave it's supposed to be? I mean, that's the way it should be, right? Somebody asks the question, you answer the question. Why aren't the width of the rings proportional to the distances in the double slit experiment? It's being caused by the same phenomenon. By quantum mechanics rules, it should obey the same rules. Alright, and so then he tells us how big a nanometer is. 1/1000th of a millionth of a meter. So that's clear as mud, right? I mean, 1,000th of a meter, I guess, is a millimeter. So technically, it's a millionth of a millimeter, I guess. But that's what he actually said. 1,000th of a millionth of a meter. Does that make sense to you? No, that doesn't make sense. If that's what intelligent people, if that's how intelligent people educate people, that's why people don't get very educated, I guess. Counting the 290 nanometer change in the position of the mirror by hand adjustment. Yes, so I guess that's all I said. That was all I wrote. I'm just saying it's really, I don't know if we can do that. I mean, I just don't know if that's physically possible. Like when they're turning it and you're getting this really smooth transition, right? I showed the video. The pattern changes very smoothly, and the argument is those are tiny percentages of a millimeter. Those are tiny percentages of a millimeter. So, again, the argument just doesn't make any sense. I mean, of a nanometer, because they're not a full wavelength. Because I think the argument is you have to go through many cycles, 18 in the case of the video I played, or 24, whatever it was, before you get a full wavelength difference, where you're back on the same wavelength again, where they're back in phase again. I think that's the argument. Now, I'm saying I think, so yeah, I'm not sure. But again, for people to be so obnoxious and arrogant, they should have answers to these questions. They should know the answer if they know it's the truth. If they're so certain of what the experiment's doing, then why can't they explain it? Anyway, let's see. The screen shows precision phase shifts beyond the physical possibilities of the adjustment mechanism. So again, I would argue that if you can do 24 turns and watch all those patterns go by, and those are 1/24th of a wavelength, then you're talking about adjustments of just 10 nanometers being made smoothly by hand. I don't think so. Anyway, he claims I continually say I don't know why. Well, I might also say you're crazy and you're stupid, but I don't know if I say I don't know why so many times. I'm just saying, why don't you give me answers? I leave questions open. I say this is curious. He thinks those are offensive words. If you say seems curious that the patterns don't match, that's offensive. 2 minutes into the video, he claims this is the extent of his analysis. Claiming it's the only analysis I've done is just realizing that the bullseye pattern is weighted wrong to be an interference pattern. It's too heavy in the inner rings and too light on the outer rings. It doesn't match an interference pattern. Let's see. So I clearly made other arguments about the fraction of the beam and refraction inside of the beam splitter. Certainly made lots of other arguments. Okay, he mocks the fact that the fringe sizes are not consistent with either the single or double slit. So yeah, he just laughed it off, mocked it as some kind of only a fucktard or could care less. Just doesn't think it's interesting. Doesn't think it's worth an explanation. He claims this is the best I can do, even though this is only one of the many flaws found in his theory. So, right, I've over the weeks listed lots of flaws in this perfect math that isn't so perfect, and in the presumptions that go into these experiments, and why they have a consequence that just doesn't make any sense. It's not consistent with what's seen in the world. Okay, claims I do not understand the basic concept at play, yet he claims photons can interfere with each other. And that means different photons interfering. Again, that was the clear implication of him bringing up that the experiment has lots of photons going into it, and so that's how there's interference. When the real quantum mechanical obligation is to demonstrate how that each individual photon takes both paths somehow. Or, I don't know how they're going to do it. I don't know how you make a rational argument for interference consistent with quantum mechanics. Because if you make the photon split in two and travel both paths, it's wave function. That seems like the only way you can do it. Because if you wait until after it goes through the instrument and then have it interfere on the final leg, it doesn't seem that can possibly work, because one photon didn't go both legs, so it doesn't have information from both legs. But again, they don't think it's important to have an image or drawing of this. They don't have to understand where the wave function is and where it collapses or anything. They're just totally not curious. It's not a question that needs to be answered. Let's see. He claims the inconsistent pattern is just a distortion caused by intensity. So somehow the intensity of the light is fooling not only the camera that images it, but our eyes, and somehow it doesn't happen in the single slit experiment, and it doesn't happen in the double slit experiment, but in this interferometer, yes, our eyes go all sideways and we can't see the real pattern. It looks bright even though it's dark. Okay. Let's see. A central power nest of energy. He said something like that. Some kind of terminology like that. A central power nest of energy. So that's how I was describing the center maxima, so to speak. That it's a central power nest of energy, and that's why it breaks the rules. Okay, he's claiming eye saturation is causing the inconsistent pattern, yet the images are taken with a camera, so it's just kind of obvious. And cameras can certainly have their flaws in terms of, as I pointed out in the most recent video, that yes, they get the exposure wrong and you won't see things accurately. So it's certainly possible, but it could also be possible that yes, you could dim the experiment by dimming the amount of light that goes through, and it could appear black when it actually isn't. And that's my point, is that there's different ways of doing this experiment, and they create different results. And curious people would want to know about those differences and compare them to be able to understand better how the instrument works. But Daftloday thinks that's offensive. Claims the human eye is a terrible intensity meter. I don't think it's all that bad. It's pretty damn good, I think. Oops, I made a mistake there. Improved value asymmetry. No, that's not the subject we're on. I don't know why. Claims I don't understand. Let's see, he's claiming the eye. Okay, there's done. We're done with the eye stuff. He claims the inconsistent pattern is exactly as predicted. So that's sort of an amazingly stupid thing to say, because I don't think he knows where there's any predictions, and those predictions are just calculated based on assumptions about the function of the device. Now, if the device isn't actually measuring the wavelength of the light in the sense that it's doing it in the indirect way by diverging the light, it's going to be much less sensitive than they think. If that's the truth, it's not measuring it's not measuring how big a proton is anymore. It might just be measuring how big an atom is in terms of the difference, and that's a huge difference, by the way. Although the instrument was produced for this singular purpose, he claims it is a rough and ready example. So he's claiming the video is garbage because it's a garbage instrument and a garbage experimenter and a garbage. And like I just pointed out, the video I played was actually not a homemade interferometer. It's a produced one. Apparently, the experimental predictions do not care with any precision what kind of pattern is created. So apparently their math or whatever, they're just not too concerned. They just care that there's a shift in patterns, and because that justifies their phase shift theory, and they just really don't care what creates it. You know, the pattern, it's almost the pattern. It's all about the pattern. Pattern, pattern, pattern. We just won't think about how it's created. We don't care. Photons interfering or light refracting, we don't care. Even though those two things have a huge consequential difference in terms of how precise your instrument could possibly be. But not interesting. I believe the counting determines one complete wavelength phase shift. That's just what I understand, so I don't know why I threw it in there, but I threw it in there because he said something. The inconsistent pattern is blah 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 evidence, so that's basically what he said. He just doesn't think it's important. So you find a defect, you find an inconsistency, not important. It is horseshit. It's just like when I pointed out that polarizing filters, using the Frisbee example, do not produce 50-50 results. That is, some of the things that are going the right way end up hitting the bars and not going through. But all of the Frisbees you throw the wrong way don't get through. So that asymmetry means it's not 50-50. And maybe that would be significant if you're doing experiments and your assumption is it's 50-50. But statistically and actually, it's not. Okay, let's see. It is horseshit to point out inconsistencies in an experimental result. So that's basically what he said. Curious facts don't matter. So if you find something curious, you find something out of line. Nope, we don't want to know anything about that. I calling a curious inconsistency, he calls that an an accusation of conspiracy. So right, merely because I point out that I don't think you can use a micrometer to change, tiny bits of nanometers in distance, that you could actually do that in a smooth manner at all, that you could make a mechanical mechanism that could move things nanometers worth of distance in anything but a herky-jerky way. No way it could be smooth. Those kinds of comments are making accusations of conspiracy. Now, I've called them all liars and thieves and crooks because I merely say they didn't pay any attention to the details. The single and double slit experiment create a perfectly proportional pattern. He claims he has explained why the interferometer does not produce a similar pattern. And I couldn't find an explanation besides him saying, well, it's because it's an area thing. And I'd make the argument that if you're going to make that argument, then Newton's rings should look very different than the single slit in terms of proportions, but they don't. Alright, he claims I have said I don't know anything about this, which, just to argue that I've said that, meaning I don't know anything about the entire experiment or the context of the experiment or other experiments dealing with light. I'm just saying I'm not an expert on interferometers. I'm just now researching them, in this argument in the last, year, let's say, that it's come up. And so I've gained some knowledge on them. So I clearly know something about them. So it'd be idiotic to sit there and say, well, that's why you can't understand. It's because you don't know anything. I certainly know enough to know what quantum mechanics says, and I know that you can't blame multiple photons for interfering with each other, and I know what the pattern should look like, and I know, according to Heisenberg, you can't avoid divergence. Even if you don't take the serious part of Heisenberg, just the non-quantum mechanical part of Heisenberg is narrow slits create divergence. It's a fact. Can't avoid it. Okay, so anything. So he claims I've said that I don't know anything. Okay, I say it's basically a lie, because obviously I never said I don't know anything in any context where I said I don't know anything at all. I certainly know what an interferometer patterns are supposed to look like. Yay me. I should be prepared to just accept the orthodox explanations. That's basically what he's saying. Unless you know everything there is to know, you have no right to find anything wrong. So only until you're an expert will we listen to your discovery. That's it. You can't discover anything until you're a qualified expert. The orthodoxy has never answered the questions of why the patterns are not consistent. So the question will never get answered because they'll never get asked. Because no one qualified is ever going to ask the question, because they don't care. Alright, he claims because I have a unification theory, I therefore should be an expert on how interferometers actually work. So because I came up with a theory that explains charge and magnetism and gravity, therefore I should know every detail about how interferometers work. That's his logic. So obviously my unification theory can't be right because I'm not an expert on interferometers. So yeah, we just can't beat that logic, right? That's just too perfect. Oof. Yeah. Alright. Let's see, that's where we were. Consensus. The orthodoxy, okay, has never answered it. Quite actually worked. He seems quite certain that accelerator particles are real players in the real physics. So he brought up in that critique where he's insulting my knowledge and my unification theory, he's making a defense of all the 100 and whatever particles they've invented or seen in accelerators. And he thinks, I guess, that these are all legitimate players in the real universe, that they're not just things broken off of things that may or may not have anything to do with any real mechanical mechanism. So he's convinced that they're all, the universe is really that complicated, that the atom has to have all these different kinds of little anti-things, and all these little bits are in there doing all their little games. But anyway, I'm just saying that's just a general critique, that he thinks particles that only last for a millionth of a second, that's how long they survive, a millionth of a second, that those are real players in the mechanism of the universe. Anyway, you're getting claims the experiment is high school. Well, anyway, he kept claiming it's a high school experiment. It's simple. Everybody knows how it works. Nothing complicated. Nothing to see here. Nothing to examine here. And I find it laughable in this context where he is so ignorant of things like the divergence of the beams. He essentially claims it is unreasonable to expect interferometer patterns to be consistent with fundamental laws of quantum mechanics. That's basically what he's saying. It's not important. They don't have to obey the laws of quantum mechanics. Fuck this whole probability crap. He's claiming I'm lying merely by observing the inconsistency and questioning how is that consistent with quantum mechanics. So again, you can just keep pointing out that quantum mechanics does have certain puts limitations on things. And again, one of the limitations is photons don't interact with other photons. They interact with their own wave function. There's just some rules, and he just doesn't give a shit about those rules. Because no one in the past challenged the experiment's presumptions, no one should ever. And that's all he's basically saying. I don't want to hear it. We've never had to hear it before, so we're not going to hear it now, and we won't hear it in the future, and that's good science. That's what scientists do, is just close their fucking door and say, I don't want to hear any nonsense about any other God. I have my God, and I sing songs to quantum mechanics. I say that's an issue I think needs explaining. Yes, I'm just saying these are all problems, and you don't seem to want to come up with a solution. So you're just pretty lazy is what you are, besides being fanatic kooks. He claims I have no authority to ask for an explanation. So again, I have to somehow be an expert, or you can't challenge anything you observe. So until an expert shows up and says diffraction gradients cause divergence, then you don't have to pay any attention to that as a problem. And that the two paths have a different amount of divergence in them, quite obviously. Fact. Let's just ignore that. Alright. When you have your head around the basics, then you can ask about intricacies. So I thought that was kind of funny. I thought it was a high school experiment. So he, so somehow, I don't have enough knowledge of the experiment to ask questions about how it functions beyond just saying, oh, are those photony thingies going through there? I can ask dumb questions, but I can't ask a smart question because I'm not qualified to do that. Saying that seems curious. That's what I said. It seems curious. Or odd is a dumb thing to say. So it's dumb when anybody says, gee, that seems curious, that seems out of place, that doesn't seem quite right. That's an ignorant man. So anybody who asks a question, why doesn't that fit? Why isn't that right? No, that's a dumbass. By Daftloaday's definition. I say nothing about what's going on in the interferometer is really simple. Yes, so that's what I've said. I said it seems to me that the more you dig into it, the more complex it gets. He replies, my excuse for not understanding is because it's really complex. He starts replaying the same video again. So anyway, it just doesn't, there's no excuse for not answering questions if you think you have the right answers. It's when you don't have answers that you start doing this belligerent thing. Say it doesn't make too much sense to me is a mockable phrase, right? So if you say something like, that doesn't really make sense to me, Oh, he's worthy of mocking. Okay. Reiterates old nonsense about how I don't understand what velocity and mass are, because he claims, I love this, he claims mass isn't substance anymore. So he thinks the new modern physics now has moved so far beyond Einstein that we don't even bother thinking that mass has something to do with substance. You can be nothing and have plenty of mass. Alright, he concedes that I was right to say nanometer is a millionth of a millimeter. Well, that part was kind of funny. You know, because he goes back and plays the same video. He's only gone like through 4 minutes of my video. And just when I was going to get to start drawing stuff, he decides to go back to the beginning again for no good reason and just do the same video all over again. I don't understand it. I'll start where I left off. I mean, I'll play some of it here, but it just doesn't make any sense. All right, he claims my videos to certain significant continuous errors. I don't know what that was. He claims total incompetency, yet he doesn't seem to understand their basic rules of quantum mechanics, right? So he claims my incompetency, and yet when tested, he doesn't seem to understand how quantum mechanics works or what the rules are. He apparently thinks you can measure nanometers with a micrometer. And again, I can't say this for sure. I'm just saying, from my own personal experience working in machine shops and stuff, I never had any kind of instrument that was nearly precise enough to make adjustments as small as nanometers. He claims I should prove it's hard to move things on the nanometer scale, and that I called someone a liar. Okay, so yeah, so he's claiming I'm calling somebody a liar merely by saying I don't think you can do that. I don't think the guy using the experiment tested it to see how much the mirror moves. I don't think he's just taking it for granted too, like everybody else, that somehow he's moving the phases of light. He's moving through the phases of a light beam, you know, by turning a little handle. You know, he's making little tiny movements in the mirror, just incredibly small movements. He talks about accuracy and great mathematics, and then says when he can't remember a formula, forget the formula. Yeah, he actually did that. He was going to write the formula, and he just said, fuck it. You know, so I mean, it doesn't make any sense. He calls divergence a splitting fanning theory, and that's part of his accuracy. So I said accuracy question mark. So divergence, the fact that this is a real phenomenon in optics, it's something else to be mocked as just kind of like some splitting fanning theory. What nonsense. He claims it would change the angles, then he claims it wouldn't change the angles. The other way around. First he claimed it can't change the angles, and then he said, well, okay, maybe it can change the angles. You know, just amazing. He predicts that a beam splitter will not create substantial divergence. So right there, I win. So he says he's purchased one. I'm going to also, but cheap. And that should be the first experiment. It's just to hold it up, shine the laser beam through it, have a piece of paper a couple inches away, and see how much the beam diverges. Because if it doesn't diverge, Heisenberg is wrong. If it does diverge, Gary is right. So see, I can't lose. One way Heisenberg is bullshit, we can throw it in the trapper, we can throw it in the crapper, and the other way, I win, because yes, I was right. So, I can't lose. Either quantum mechanics is thrown in the bucket, or Gary's right. Those are both good endings. Alright. If it doesn't, then Heisenberg theory is in jeopardy. I said it a more polite way there. He states the experiment is confirming a calculation. So this is the funny part, right? They calculate on a piece of paper based on their wrong assumptions, and they figure, yes, we're measuring the thickness of a proton, because they've wrongly assumed what they're measuring, what's causing the effect. And if the effect is being caused by divergence, then it won't be anywhere close to the thickness of a proton. He again states it's a really basic experiment from the classical point of view. So somehow, I don't even know what this classical point of view is supposed to be. But again, how is any kind of wave interference classical? Certainly not Newton's theory. So that's Huygens. And Huygens is classical now? I don't know. I don't know how you use these words. I mean, I still don't understand how this is classical mechanics, something like photons interfering with each other. As if photons interfering with themselves is basic. Yeah, like I'm saying, that's not basic. That's certainly not Newton. Or each other, okay, you know, with themselves or each other. So both are challenging. Clearly, I don't think there's any experimental evidence of different photons interfering with each other. So I don't think you're still stuck with just explaining a single photon interfering with himself. And to call that anything called classical, how is that a classical theory? Not even close. He claims I don't understand why and what's been shown, when it seems clear he doesn't understand anything in this experiment. He claims that counting over a larger distance somehow makes nanometer adjustments possible. So this part was kind of strange because he's basically he's making the opposite argument. So when I'm talking about this adjusting, I'm talking about this nanometer distance. 1/millionth of a millimeter is what you have to move the mirror to get changes. You know, well, not 1/millionth. You can move like 10 or 20 millionths of a millimeter to get this change. And if you're just moving one phase shift by counting all these cycles, then those movements are even smaller. So you're talking about just 5 nanometers. You're moving the mirror smoothly in 5 nanometer increments. It just doesn't seem possible. Asking questions why means you don't understand anything entirely. Yeah, so whatever. So you can't ask why. It's forbidden. Forbidden to do. I don't know why it keeps doing that. Well, all these programs are a little bit. You say, why does it do that? Why did it do that? Alright. Asking questions why since you don't understand anything entirely. Yeah, that's the end. Okay. So let's go to his crappy video, and we'll suffer some of that because I love you. Oh, maybe I don't. Yeah, no, it wouldn't be for that. It should be loud enough, but make sure I have a little bit of juice to it.
The entire explanation of what's going on here, right? You needed to hear that twice because you really are an incompetent ignoramus, yeah, when it comes to these things.
Right, and I'm just, you know, we could just go through the things that he hasn't in any way rationally explained, and he certainly didn't rationally explain them in this video. So I just go to the previous videos, the other 13 Daftloday videos, and you'll see. Ah, there, I'm drawing, but no sound.
Oh. So let's get it back to the drawing.
Pipe bars are very different in size. Yeah, so I'm just going to give it a shot.
Unfortunately, this is just going to be the distance argument, I think. So it's not a very interesting argument because that's just one wacky person who thinks the absolute frame is the same as an ether frame.
Let's see how it goes. So the idea is there's 2 paths. Okay. Oh man, you could draw a little bit better than that, couldn't you? All right. So this is the start, let's say, and this is the finish. Just call it next. And the idea is you go these 2 paths, and then you go through a bunch of mirrors, and then you go right down, back and forth through the mirrors, and then back. So this one is the same.
There we go.
That's not. I mean, this is what was laughable. This drawing is going to make. Looks nothing like what goes on in the interferometer. There's not this whizzing about bouncing look.
Yeah, see, I mean, he's an idiot, right? I'm drawing the Michelson interferometer. The Michelson interferometer has 18 mirrors in it. 18. The light goes bouncing a lot in both arms. And he doesn't even know that. He doesn't even know that the Michelson interferometer is dependent on using mirrors to create extra distance.
The times inside a mirror, is there?
Mirrors going this way. All right. So the argument is that yes, this is really nice for adding distance, but this doesn't work. Is my argument. So the argument is
No, the short interferometer is just short. Yeah.
Right. It was the Michelson interferometer. It has a name, okay? And yes, people use that word to describe any interferometer. But this video was a response on the subject of the Michelson interferometer. It's not a response to somebody with a little interferometer. It's a response to somebody arguing the Michelson interferometer experiment. Asshole. Shit, he's not even paying any attention.
It doesn't need a long distance if there's no bouncing about. This experiment isn't done like that.
Yeah, no, we're talking about the experiment that measured for the ether, idiot. You don't measure for the ether with a foot-long interferometer. You can't do it. There would be no hope of doing it. You have to have a longer interferometer to do that, shithead. You can't do it anyway, but the point is, if you're going to try to do it, yes, you have to have a longer distance to have any hope of doing it. It's like you have to have a telescope to be able to see stars and shit, asshole. Like lensing or something. You can't just look up into the sky and, oh, I'm seeing it lensed.
It isn't short because they've done this with the mirrors, right? They'll be directly reflecting it back. Yeah. I'll be corrected on that, of course, if I'm wrong. But
yes,
you're
just being an asshole. Yeah, I'll be corrected on that. In hindsight, I was wrong. Oh, gee, that's just so cute. Just make errors and don't care about the mess your errors make. You'll just put it on page 10 the next day. Sorry, I lied. Sorry, I was full of shit. Yeah, I don't care. Your reputation's ruined. Oh, that's okay.
He's heard them say it's a short interferometer and presume that there's this happening. Well, no, they'll be reflecting it back, and that's all there will be to it.
So again, this was response to the specific argument about their distance change in the arms of the interferometer when you're measuring for ether drag, which is dragging the ether with the earth, or dragging the frame of the ether with the earth, or some other theory like that. It goes back to ether theory, shithead. The very purpose of doing the experiment in the first place. The experiment was invented for this purpose, not for your purpose. Not for finding gravitational waves. That's not what it was invented for.
And you call the first instance of time when this beam goes through, going through the beam splitter is here. So it goes through, this beam goes through and this beam reflects. So this beam goes through it, and then you have to think about it.
I mean, look how tiny that drawing is on the screen. And you're just going to scribble, you've got all these scribbles. You could have used the space he had available,
How the mirror is moving and the fact that the glass slows the light down, and so it's going to be in the slower glass longer, but we'll just ignore that for right now. So let's just call this a starting point. So that's T0. And so as the light travels,
I understand that. I have been playing with this technology and I haven't perfected it yet in terms of, I don't even like the exposure on that exactly. So I'm getting better at drawing bigger and all that kind of crap. So again, just a stupid little petty critique. But whatever. Fuck you.
First mirror is now moving this way as the light's traveling towards it. So that means it's going to be at a different position at T1. And so when the light goes back, it's going to start from this position, and now the beam splitter is now going to be moving forward. So
the beam splitter is moving forward. No, the beam splitter is stationary.
When this one leaves at T1, and
so I don't know. I probably shouldn't even play this, right? Is there any point? I mean, he's so clueless. He doesn't understand that why the Michelson-Morley experiment is famous is for this exact purpose, and that I was responding to people claiming that this instrument can measure speed of light changes or something because you move the instrument. that somehow it detects something, some field thing. And I was just asserting how it can't possibly do that because the distances always turn out to be the same. The device is moving half a day, okay? The idea is it's moving on the Earth, and they think because it's moving on the Earth, one arm has a different distance than the other arm.
At T2, when it gets to the beam splitter is going to be closer, so you can say, like,
no. If you move the mirror further away, as far as the reflecting beam is concerned, the beam splitter is further away, not closer.
We got this stuff in the way here. So we just, for the sake of, we'll call this T2.
So again, it's just always laughable. He doesn't realize we're talking about the whole instrument's moving, idiot. It's moving 50,000 miles an hour in a direction in space, and that's what they're attempting to detect, idiot.
3. Alright, so T3 means the mirror's a little closer. So,
How is it closer? It's just nonsense.
this
How is what closer? You've moved it further away and something's got closer.
distance from this arrow, from this further away.
So apparently he didn't even pre-listen to the video he was going to respond to. And, you know, I, of course, can do that because I'm fucking brilliant. But clearly he can't pull it off because he just doesn't understand the context of this video at all. A fucking dolt.
Position, but it's really, it's not further than this one. So this distance is your real distance.
What's now he's got these marks? What's not further away than what's not further away? I already heard you say it's further away, but now it's closer. And now
Yes, the machine is moving. That means the parts are moving away. I mean, I pointed it out in my last video, and he still can't even make that connection when I was talking about, you know, answering the comments section. And I pointed out how, well, if you leave for work and work is running away from you, it'll take longer to get to work. But on the way home, when you leave work, if your house is moving towards you, then it'll take less time to get home. He's just completely clueless. This is a jump ahead. I want why torture the idiot. See if he gets to. Maybe I'll get to another point here.
Longer, and then this one ends up going shorter, and this one ends up going longer. So
what the hell?
in the mirrors, you don't do the same thing you're doing on this first length. So the mirrors, it all cancels.
Yeah, so he still doesn't get it. He still doesn't understand. It's an experiment that was used to detect glue movement, a stream moving. So as the stream moves, you go against the flow or with the flow, it would change the speed of light. So he just doesn't get that that's what the thing is about.
There's no increase in...
Sure that. I mean, it's alright just waving your pen and saying, oh, and it all cancels out. Now, I show the wavelengths and exactly how simple it is when...
It shows the wavelengths by drawing a wave and then drawing a wave out of phase and then say, there, I've done my job. I've explained how the machine creates that. No, you haven't done that.
Things are adding and when things are cancelling.
Things are adding and canceling. What things? By quantum mechanical law, the thing that has to be adding and subtracting is a wave function. So why don't you explain where the wave function is and where it gets added and subtracted?
Yeah, it's not followable in this diagram. That statement holds any water. What does follow is that it's easy to say it, real easy to say it. Oh, and I mean, like I said, I think your schematic's completely wrong. But
okay, so it's not. It's a really complex idea to say there's two things moving like this. That's what they're doing. They're moving like this, and that when you're going this way, it'll take longer to get to this one because it's moving away from you. And when you're going this way, this one crashes into you sooner. And that it would be exactly the same a difference. The length of the longer, because the two things are moving exactly the same speed. The length longer you go this way is exactly the same as the length shorter you go this way. That I have to prove with what? What do you want me to prove that with? It's almost too that's almost so basically put. How do I prove that to you? It's so obvious. The two things are, they're not moving towards each other. They're locked and they're moving together. How is it possible to create a difference in path, total path? Fuck. God, you people just so suck. You're just too stupid.
but those cycles don't represent. So,
Well, he's going to tell us what those cycles don't represent. After admitting at the beginning of the video, he's no clue as to why and what it's about. You know?
I never.
Cycles. No, this is way more
I never did any such thing, so that's just crap.
complicated than I don't know if I can really show anything.
No, you won't be told or hear the simplistic part. Yeah? You'll get all upset about the thickness of a line or the thickness of a dark spell, when the experiment isn't designed to demonstrate that feature of.
Oh, it's not designed to be accurate. It's not designed to match quantum mechanics. It's not designed to be consistent with all the other interference patterns. It's designed just to serve our purpose of finding gravitational waves. Okay, got it. Don't ask any questions. No. You're bad. You're a nasty person. You're asking questions. Oh, here I'm showing the laser part. This ought to be worth it. Yeah, let's go back so we don't miss any of that.
It doesn't have a randomized deflection.
You're just babbling now. You're just babbling.
But you can see it creates a lot of images.
No, you can see you're making a lot of images with a completely different experiment.
Okay, so he says the diffraction film is a completely different experiment. Completely different from a half-silvered mirror. Where the hell is it, by the way? I keep losing it. There's a lot of stuff here. A lot of crap in my life. Well, it's not here handy right now, but I know it's here. Yes, I can't see it, you know, it's clear. It's a problem. So he says it's bullshit to make a comparison with a thing that has, yes, these are very geometrically lined up little holes. But the half-silver mirror is the same principle, except they're randomized. But the divergence is the same. It's diverging in all directions. Every single little hole creates huge divergence. Very similar principle. So he's just full of shit again.
And so the fact that he's seen a lot of images allows him to say, oh, it's so complex, whatever they're telling you is simple, and it looks simple, and it simply fits the predictions, but, oh, look at this, it's so complex.
Again, so it fits what prediction. So again, they keep using this word that somebody predicted something, and we don't see any of those predictions about what it did. Again, I point out, we're not even shown any examples of LIGO doing something brilliant. There's not one example of them showing us an experiment that the LIGO did where it detected something like half the distance of a proton. We didn't even get it to detect a Volkswagen on the road, or, as I pointed out, a Volkswagen swinging over the beam. Because technically, if this theory is correct, that should disturb the beam. We didn't see any test that demonstrates the instrument has any of the precision they claim. No test at all. Not a single test. And that's okay with him.
I don't understand it, but I have no theory for it. I know I've just unified all of physics, but I can't explain this simply.
I am explaining it simply. That's exactly what I am doing. I'm giving you a simple explanation for why the experiment does what it does. And I put two things together, refraction and the divergence I've been talking about for months. You keep claiming this divergence doesn't mean anything. I kept claiming it's in the experiment and it should be accounted for because it's a real thing. One length of the interferometer diverges many times more. I mean, not just lots more, but a lot more than the other leg. A lot more. The substance of the whole distance over and back. That much more distance. And, you know, who cares? Not important. Yeah, no, I think it's really important. I think it's the whole reason why the machine works, is that divergence.
The question will be, are those images spaced similar to the spacing of the ringed pattern? Can do a reflection.
You know, the questions you need to address is understand the experiment first. Yeah.
So understand it in what way? Through what mechanism do I understand it? I've read the Wikipedia pages. I understand some of what they say, but in none of those explanations do I get any example of where the Huygens thing happens, where the photon turns into two photons, two wave functions, and the wave functions interfere with themselves, and then the photon turns back into a single photon again. I don't see any diagrams of where that takes place in this fucking experiment. I don't see any quantum mechanical explanation for how this fucking thing works. Just a bunch of claims that it works. No actual drawings or representations of the mechanics, how the photons flow through the device. Nothing to explain how you're measuring wavelength shifts. How the photons do their interfering.
So I'm going to make a beam splitter out of this. And
like you said you're going to do, and I've done, beam splitters on order. This will be resolved, yeah. And
like I said, I can't possibly lose. All right. If the beam doesn't diffract, I have clear evidence that Heisenberg is bullshit. Because there'll be no way for you to quantum mechanically explain how the tiny holes in the mirror didn't diffract the light. There'll be no way to explain how that didn't happen. So I can't possibly lose if you use the beam splitter and it doesn't do exactly what this beam splitter does, which is this diffraction gradient does, which is split the beam to pieces. I mean, all over the fucking goddamn place. I don't know whether you can see that, but there's dots everywhere. All over the place they shoot.
That's the beam diverges. I don't expect it to be more than 50%, yeah, but it definitely won't double. Yeah.
Okay, he says more than 50%, but it definitely won't double, and that's supposed to make sense to somebody too, right? Some people would say that would be doubling would be a 100% increase. So we're just talking about the beam getting thicker, and as I pointed out, this isn't going to even be close. The beam won't just be a little bit thicker. There's going to be stuff all over the place, and it's going to be in the form of rings likely, and those rings are going to be really far from each other. So unless he does the experiment right, that is, point it at the wall, get a foot or two from the wall, shine the laser beam through it, and just see how much crap is all over the place. Because it's going to be all over the place. Yes, 85% of the light will be right in the middle, but a ton of light is going to be diverging. Well, 80%, I don't know. Don't quote me on that.
With half-meter legs, with a simple shitty red laser, you know, I'd be disappointed if it's... Well, it depends. I mean, I'm only getting eBay beam splitter. I mean, there are sites, you go to scientific optic sites and get the proper job as well, so that might be where we have to go, but...
it'll have a bias.
But you see, you know, the more complex... The reason I'm so confident is, you
can be confident. The reason why I'm so confident is because they use diffraction gradients, these beam splitters on lasers all the time to create images on walls and shit, so it's already a proven science, so, you know, I think you're out of luck.
See a lot of optics experiments and optics tables, that metal, highly accurate metal hole drilled and all those things. You can see a lot of optics setups where there are lots of beam split.
Yes, well, whatever. That was exactly the video I played, was one of those precision-made instruments for exactly this purpose. It wasn't meant to be anything other than an interferometer, and it was a precision-made, machined instrument.
So there's lots of reflectors, and if these objects were introducing huge fanning divergence of the laser beam, then there's no point in the experiment. Yeah, that's why they use lasers, because essentially it's parallel light.
Well, exactly, but it's exactly my point. So what I'm going to argue is taking place is that that's why look, it's always been something I noticed, and maybe you noticed in the MIT. He's got a big, powerful laser he shoots into the interferometer, right? It's this long. So it's making a pretty hot beam. He shoots it through this little 2-foot long, 3-foot, 4-foot long, whatever, interferometer device. And the images are dull and weak. You know, you have to lower the light to see them. And why is that? Where did all the light go? And so that always did bother me. So yes, what you're going to get is the center is going to be thicker and bigger. So it will diverge by 100% at least, or more. Probably a lot more. Probably 400, 500% maybe. and there'll be rings of light going out, weak and strong rings. It just depends on how it's randomized. How the holes in the mirror are randomized will tell you how much character the image has. But it's going to spread. A lot of light is going south, or west and east.
And it goes through the optics table, maintaining a pretty narrow spot. It's my belief, anyway.
Is that it won't be.
We'll see.
And I can use 2 pieces and then go. What else do I want to? I really wanted to go into this a little better than I just did. This distance.
Right, so you acknowledge what you just did was a load of shit. It was just a load of ramble around a tiny scribble.
So the difference in the distance means.
Yeah, well, the tiny scribble, like I said, people could see it in the real video. Obviously, he's got my video really small. It wasn't that bad. I mean, come on.
Something, only in the sense that you're not comparing this beam. I guess I could use red.
If you knew why the counting was half a wavelength, yeah, you'd understand exactly what the beam length meant in the optic, but you don't. Yeah? So this is fairy tale, imagineering, just so stories about how you'd like.
Right. So he thinks he understands what they're counting, and by his theory, if they're counting to get to one wavelength shift, that is one phase shift, then those 24 rotations had to be going through tiny numbers of nanometers of distance, and he thinks you can do that with a little handle you turn with, like this. You can move something nanometers with little turns of your hand. I don't think so.
To say you think it works, and how you'd like to say how it really works in your crackpot theory.
Let's see if it works. Yeah, that was purple. You're not comparing this distance to this distance in the interferometer. I mean, obviously the 2 beams you're comparing is this other leg going this way and the leg going this way.
Say it simple, and we all understand it. Who understands interferometry?
Okay, so he says he understands it, yet he doesn't understand why Michelson-Morley is famous, and he certainly doesn't understand the argument I was making here, which was you're not comparing the motion of the beam going this way with the motion of the beam going this way. So there's no way to detect any difference. If there was an ether, you couldn't even detect it that way.
We're comparing, if that's even the right word, the path length down one leg and back to the path length down the other leg and back. That's it. Easy peasy. Say it like a weezer.
Yeah, whatever. Jokey, smoky, pokey dokey. Yeah, whatever, you asshole. I mean, you're just totally off. You're wrong. And you're just proving my point. You're just reckless, sloppy. You don't give a fuck about the truth. You don't give a fuck about being right or wrong. You don't give a fuck about making a huge mess and being an obnoxious asshole.
So this distance doesn't mean too much. I mean, a change in the distance, if the setup is wrong, it doesn't really matter.
So it could be a little bit hard because he's made one mistake, and he's made, I mean, it's a big mistake with these extra mirrors, and he's making a whole hour-long video.
Okay, so I made a big mistake by duplicating the Michelson-Morley experiment the way it actually is performed. Oh, okay. Fuck you.
Confusing and confounding himself about these extra mirrors, when that's right, they're not there.
Because all you're looking to do is get that pattern match. So is how far, how many times it.
I mean, can you get more ironic? He's talking about how I'm making a fool out of myself by being wrong when he's just totally wrong.
So you're just basically counting how many collapses there are. And
why bother? Why bother repeating yourself? He just does this. It's got to be an hour long. All videos got to be an hour long. Yeah. So he goes back and he's counting. I don't know why. Look, he's counting the fringe thicknesses. The ratios, the thicknesses.
So again, nothing is important. You can just mock all of it. Fine. I'm just saying you're the one showing me this is the attitude of the people defending this suspect science, and you're just demonstrating exactly why it's suspect science. Because yes, all of the minions are like this. This is what the science is made out of. A bunch of dullards who just couldn't give a fuck about the facts.
The proportions don't agree. I don't know how to make a prediction, but that's not how it should be. Oh, they're lying.
That's supposed to tell you where the number is.
So, no, you're lying. now you're the person I call a liar. So go show where I've called somebody else a liar, where I called the professor a liar, or where I called some other guy doing a video on YouTube a liar. Show that, asshole. You're the fucking liar. Lying about who I lie about, lying about all kinds of shit. You're just such a fucking liar. You can't be fair in an argument ever. You're a compulsive cheater and liar.
Whatever light you're using, that number represents a half a wavelength, or a 90-degree shift in wavelength. Apparently, that's what I can glean from this. So, but again, look just how consistent the black lines are, and how inconsistent.
You see, it's just repetitious. Endless repetitious. If this was a video response to a person, it would be endless, you liar, you're disgrace.
Okay, so I didn't do any of that, so he's lying some more. What I just did was, until somebody gives me an answer, it's an unanswered question. Why is the pattern not consistent with other interference patterns? If it's interference, why doesn't it look like interference?
You're, low down, arrogant, obnoxious, blah, 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 for an hour.
The size of the red lines are, it's complicated going on here, somehow compensates for these differences in length by somehow staying in phase.
Oh, somehow, it's all a mystery. Somehow it all does it counting diffraction.
All right. So this is the reaction, right? So instead of answering the question, they just mock anybody who asks a question. Got it. I mean, you're just showing exactly why there's a problem, why the physics is broken. It's because this is the attitude of the faithful. They're all idiots.
Somehow, but I don't know.
When it should be out of phase or something is the argument. Somehow light knows the distance is different.
See, all this somehow, he thinks this is intelligent, quizzical behaviour. Yeah? When you have a basic grasp of the physics, all this is ignorant, blind, fumbling in the dark. Yeah.
Yeah. So again, he understands, and that's why he can't provide an answer. It's because he understands.
I would argue you can't do that.
Well, no, you wouldn't argue. There's no argument here. 90% of the times when you say, oh, I would argue, like you've watched in the legal films perhaps, in the legal series, I would argue this. No, you're not arguing anything, you're just saying, yeah? Replace...
Right, I don't make arguments on the internet. It's all I do, isn't it? Come on, any honest viewer is going to say, no, Gary makes a lot of arguments. It's amazing, I don't know, what can you say? This guy is just so fucking pitiful.
I would argue too. I don't understand it, so I'm saying it doesn't work like that. It works this way.
So anyway, I'm going to turn it into a relativity experiment somehow.
Yeah, like oh. This is the other thing. Oh, and so...
Okay, so we're back to the idea of the Michelson-Morley experiment, and clearly the guy I was arguing with in comments, and this video was a response to, was arguing that it's a frame movement thing, and I was waiting for him to say something like, well, the photon is time dilating in one direction and it's not time dilating in the other because the frame is moving, or some kind of horseshit like that. So we're almost there. I bet it'll show up eventually. I'm sure they'll do that to Michelson-Morley. There'll be a little time dilation in there somewhere.
This is the other thing where he goes, next they'll be going, oh, bent space, double slit diffraction, Heisenberg, Huygens,
yeah,
blah,
dark
blah, blah,
matter,
blah. All off subject,
all the made up little fucking canards of science. I did a great line in the last video, and towards the end I was just saying, this is where science put its head up its ass, was the two-slit experiment. That's when science officially put its head up its ass.
Just to convince you that he knows something.
Exactly get how they're doing that because again you're not comparing.
Yeah, you have no clue, do you? Yeah?
This forward distance.
I don't know exactly how they're doing that, but you're not comparing. You have no idea. Just leave it at that.
Against this backward distance, you're comparing the distance, the time it takes a light to go through this pattern against the time it takes the light to go through this pattern.
Ramble, nonsense. You're not comparing times to go through. There's no stopwatch.
Yeah, the stopwatch is the out-of-phaseness. That's the comparison in time, idiot. You see, if it takes you a little bit longer, that means you're out of phase. Dumbo. I mean, he talks about how I don't understand what the experiment's doing, and then he says something so stupid as, the experiment is not measuring time. Well, yeah, that's really what it is doing. It's measuring how long it takes. for the photon to get to a place. And the longer it takes it, the more out of phase it's going to be. Well, the more possible wavelengths it's out of phase.
You're counting recursions of the pattern. You understand the recursions of the pattern to mean something in terms of the theory. You count the recursion.
No, I really don't understand what they mean in terms of quantum mechanically how they're being created. So why don't you explain how they're quantum mechanically being created?
Of the pattern over a distance, you've negated the fact that you can't adjust it on nanometer scales, because you can then average and find out the wavelength. No, I don't know how to do this, and I would argue you can't do this. They've done it, and there's no time involved at all.
Especially as you're trying.
Okay, they've done it. So again, there's no, you can't criticize any experiment because they've done it. Can't point out how polarizing filters have a catch because they've done it. Okay.
Experiment, then you're starting to move these mirrors a lot more as they become relative.
So this is now talking. He's trying to explain it through to himself, and he's doing a terrible job. This is learning, trying to learn as you make a video, and it time and time again demonstrates his incapacity to learn. Yeah, and he's seen this probably several times, and he still can't make any sense of it, going through it slowly. So that's as much suffrage I'll give you of this video.
Yes, well, whatever. Just keep making them, asshole. I mean, you're on a real run. You haven't made 10-15 seconds worth of rational commentary in your last 6 videos. I mean, you're just on a huge, gigantic losing streak, so keep it up. And again, videos of this quality just make me more confident in being able to explain to people this is why physics is broken, because these are what the devotees are made out of. They're not curious, they're not fair, they just, and they don't want to be accountable. They don't want their science to be accountable. They don't want it to have solid integrity. If I make the accusation it's weak evidence, they don't show how it's strong evidence. They attack me. They don't like that message. They don't want to hear that. And they certainly don't want to accept it as a truth. So, fuck you.
Yeah, just to demonstrate what an incompetent ass we're suffering.
So again, he calls me the incompetent ass when he wasn't even competent enough to understand why Michelson-Morley is famous and why the device is named after them. It is, too ironic. Anyway, alright, the end of that. So that might be the last Daftloday video for a while because it's just a waste of time. He has no interest in providing anything besides off the top of his head rationalizations for the stuff that doesn't fit, and it's just useless drivel. It's like what he did with the lensing experiment when he just started. Well, maybe UFO light bounces off one of those and it go and. What it could, they've done it. That's all you're going to get. There's just no point. So anyway, till next time, thanks up.